Never has so much technology and brainpower been applied to improving supply chain performance. Point-of-sale scanners, followed by electronic data interchange, allow companies to capture the voice of the customer and spread it throughout the entire chain. With flexible manufacturing, automated warehousing, and rapid logistics, companies can then respond quickly.
Still, the performance of many supply chains has never been worse. In some cases, costs have grown to unprecedented levels. A study of the food industry estimated that poor coordination among supply chain partners was wasting $30 billion annually. Other supply chains suffer from an inability to match supply with demand. One department store chain found in exit interviews that 25% of its customers had left empty-handed because they were out of the specific items that the customers had come to buy. At the same time, the price on many other items had been deeply marked down because they were in excess supply. The last few years have produced a flood of ideas for dealing with these problems. New concepts like efficient consumer response, quick and accurate response, mass customization, lean and agile manufacturing. So many new ideas have been suggested that the problem now is deciding which of these new concepts to pursue. Managers need a framework to understand their environment and to develop an agenda for supply chain improvement that's best for their company's unique situation. 10 years of research and consulting in industries as diverse as food, fashion apparel and automobiles, the output of which we see around us here today, have enabled Professor Marshall Fisher of the Wharton School at the University of Pennsylvania to devise such a framework. Professor Fisher, welcome in our gallery and thank you for accepting to be our guide.
Thank you. I'm happy to be here.
Professor Fisher, what have you learned from your research and consulting that can be helpful to companies who want to improve the performance of their supply chain?
I've learned that it's a mistake to simply imitate successful companies or adopt what is currently perceived as best practice. The question is not what is best practice, but what's best for you. A company will get further faster if they first understand their environment and then develop a supply chain strategy that's best for their unique situation. And this strategy may be totally different from what other successful companies are doing.
That sounds good, but how does a company actually do this? For example, what characteristics of their environment are important in designing their supply chain?
Not surprisingly, I found that the most important characteristic to consider in designing a supply chain is the nature of the demand for the product you are supplying. So let me illustrate with a couple of products. The first is good old-fashioned Campbell's chicken noodle soup, and the other is fashion sunglasses. And the question to consider is, how does the demand for these products differ? And how do those differences affect the way we would supply these products?
Yes, that's certainly an interesting question. I'd never really thought about something like this before. But I suppose that the demand for chicken noodle soup must be pretty steady throughout the year. Maybe a little higher in the winter, I suppose. And that, therefore, it would be pretty easy to predict how much you'd sell each week. But with sunglasses, I guess, since they mostly sell in the spring and summer, it must be pretty hard to predict how well some way-out style like this one here, for instance, is going to sell.
That's right. And a fashion sunglass firm will design mostly new styles each year. And they have many different styles. For example, Bausch & Lomb, the leading manufacturer of fashion sunglasses, has about 2,400 styles.
Really? I'd never have guessed they had so much variety.
Yeah, and with all that variety and so many new styles every year, it's very hard to predict the demand for any particular item. And the fact that these styles have such a short life cycle, just a few months, means that if you do misestimate demand, you don't have time to react. You're going to end up with too little supply of some items, resulting in lost sales, and excess supply of other items, which have to be marked down for clearance, maybe even sold at a loss.
Yes. I can certainly see that making supply meet demand for sunglasses would be really hard, and the cost impact must be enormous. Sunglasses must be a high profit margin item, so a lost sale would be very expensive.
Right. Sunglasses like these sell for about $100, and as you can see, they're just a few pieces of plastic glued together, so they cost almost nothing to make.
And Campbell's chicken noodle soup must be the completely opposite case. It's a price-sensitive product, so I imagine margins are lower. The products have been around for as long as I can remember, so the life cycle must be extremely long too. And judging from what I see when I go shopping, the variety of soup products is fairly low. Certainly nothing like the 2,400 kinds of sunglasses.
Good insights. Now the question is, how would these differences between the two products affect the way we supply them?
The big problem with sunglasses would be demand unpredictability. Stockouts would be both very likely because of the demand unpredictability and highly expensive because of the high profit margin. So I'd want a fast supply chain that could respond quickly to volatile demand. With soup, I wouldn't need to be so responsive because demand is more predictable. But the price-sensitive nature of the product means I would need to be highly efficient to minimize the cost of production and transportation.
Excellent. You are really grasping the key ideas very quickly. Now, let's see if we can summarize what we've learned about how to align supply with demand.
Step in devising an effective supply chain strategy is to consider the nature of the demand for your products. Either your offer is primarily functional, like soup, or primarily innovative, like fashion sunglasses. Functional products include the daily staples of life that we buy in a wide range of retail outlets, from grocery stores to gas stations. To satisfy basic needs, and because basic needs don't change much over time, these products have long life cycles and stable, predictable demand. A supplier of fashion sunglasses, however, faces exactly the opposite kind of demand. Each year, most of the company's product offering consists of completely new designs for which demand forecasts can err by 100% or more. And because the sales season is just a few months, there is little time for the company to react if it misreads the market. Innovative products with their high margins and volatile demand require a fundamentally different supply system than stable, low-margin, functional products do. To understand the difference, it's helpful to recognize that a supply chain performs two distinct functions. The first is a physical function, which includes the conversion of raw materials into parts, components, and eventually finished goods, and their transport between the various stages of the supply chain. Less visible but equally important is a market mediation function. This boils down to ensuring that the mix of product variants which is brought to the market matches what customers want to buy. The physical and market mediation functions each incur distinct costs. Physical efficiency implies minimizing the costs of production, transportation, and carrying inventory. Market responsiveness, supply chain costs, arise when the supply of a product either exceeds or falls short of demand. In the first case, the prices have to be brought down or selling has to take place at a loss, whereas in the second case, sales opportunities are lost and customers leave dissatisfied.
Look, let's stop for an example here. The fashion sunglasses producer, whom we introduced to you earlier, faces high market mediation costs because of the uncertain demand for his product. His company will lose money on the styles that don't sell on the one hand, and on the other hand, miss sales opportunities and the resulting profit margin when stockouts occur. So it's quite clear that functional and innovative products require a different focus in their respective supply chains. It's this conclusion which lies at the basis of Professor Fisher's model. I rather fancy these. Are these props for sale?
Professor Fisher's framework links the nature of the demand with the function of the supply chain. The 4 cells of the matrix represent the 4 possibilities of product strategy versus supply strategy. Depending on the nature of the product demand, we get predictable for functional products and unpredictable for innovative ones. And depending on the priorities of the supply process, that is efficiency at the lowest possible cost or responsiveness at the fastest possible speed. Companies can use the matrix to formulate a supply chain strategy for each of their product families. They should first plot the location of the family in the matrix, then decide where the family should be, and finally develop the appropriate supply chain initiatives based on that positioning.
So, to plot the location of each product family in the matrix, Professor Fisher, you begin by looking at the nature of the demand for the product in question?
That's right. If you're like most managers I've met, you can distinguish intuitively between functional products with predictable demand and innovative products with unpredictable demand. The unpredictable innovative products are the ones which generate all of the supply headaches. In case you'd like to confirm your intuition, the grid at the end of the booklet, which you have received with this program, offers some guidelines for classifying products as either functional and predictable or as innovative and unpredictable. The values are what I have found to be typical based on my research and consulting with a wide range of companies. If you're like most companies, you'll have some products that are innovative and some that are functional. For example, Bausch & Lomb makes these innovative sunglasses, but they also make this saline solution for contact lenses, which is a functional product, sold in limited variety with predictable demand. Once the nature of demand has been established for each of your product families, you can consider the appropriate supply chain for each family. Again, if you would like to examine the differences between efficient and responsive supply chains in greater detail, there is an overview at the end of the booklet which lists the most important ones.
Right, let's look at the 4 possible combinations in Professor Fisher's model, shall we?
An efficient supply chain is a good match for functional products. Because of their predictable demand, market mediation is easy, and companies can focus almost exclusively on minimizing physical costs. Given the price sensitivity of most functional products, this is crucial. Physical costs are minimized by freezing assembly schedules for finished goods a month or more into the future. This allows companies to run manufacturing resource planning software, which determines requirements for all supplies. It also enables the entire supply channel to minimize inventory, reduce setups, and maximize capacity utilization. As suppliers, manufacturers, and retailers coordinate their activities to meet predictable demand at the least cost, the important information flows are within the channel.
So I suppose this is different for innovative products.
Yes, indeed. With innovative products, decisions about inventory and capacity are not about minimizing cost, but about where in the channel strategic reserves and excess capacity should be positioned to best hedge against demand uncertainty. And suppliers should be chosen for their speed and flexibility, not for low cost. The risk of shortages or excess supplies is very high with innovative products, for which the market reaction is uncertain. On the one hand, the high margins and the importance to quickly establish a market share increase the cost of shortages. On the other hand, the short product life cycle of innovative products increases the risk of obsolescence and the cost of excess supplies. The key in this environment is to read early sales or other market signals and react very quickly. Thus, the crucial information flows are not just within the channel, but from the marketplace to the channel, such as early consumer sales or results from customer focus groups.
So for innovative products, market mediation costs dominate, and they, not physical costs, should be the primary focus. The match is thus in the bottom right corner. Once you have plotted each of your product families in the matrix, you will see whether each of your current processes for supplying products is well matched to the product type, an efficient process for functional products, and a responsive process for innovative products. A product family located in the upper right or bottom left corners signals a problem.
You know, Professor, this all makes sense. And I think I understand it. But I would appreciate your explaining in more detail what's wrong with being in the upper right or lower left corners of this matrix. For example, what goes wrong if we emphasize only efficiency for innovative products?
Let me assure you that the argument is a very simple one. Look at it like this.
If a company is in the upper right cell, then $1 invested in increasing supply responsiveness usually reaps more than $1's reduction in the cost of mismatches between supply and demand due to stockouts or forced markdowns on excess inventory. Consider a typical innovative product with a contribution margin of 50% and an average stockout rate of 20%. The lost contribution to profit due to stockouts is huge. 50% times 20% equals 10% of sales, an amount that usually exceeds profit before tax. In this situation, the economic gain from reducing stockouts is so great that intelligent investments in supply responsiveness will always pay for themselves.
Progressive companies must have discovered this quickly. Can you give us some examples, Professor?
Well, Compaq, for instance, has made a conscious choice to keep production of certain high-variety, short life-cycle circuits in-house rather than outsource them to a low-cost Asian country. The reasoning behind the decision is that it gave the company increased flexibility and shorter lead times. Another example is World Company, a leading Japanese apparel manufacturer. They produce their basic styles in low-cost Chinese plants, but keep the production of fashionable styles in Japan. The advantage of being able to respond quickly to emerging fashion trends more than offsets the disadvantage of the higher Japanese labor costs.
I see.
Shall we now go back to the matrix to illustrate why this logic does not apply to a functional product?
Yes, let's do that.
For a typical functional product with a 15% contribution margin, an average stockout rate of 1% implies lost contribution to profit of only 15% times 1% equaling 0.15% of sales. A negligible cost that doesn't warrant the significant investments required to achieve increased speed and flexibility.
Maybe you could give us an illustration of such a product to offset against the innovative ones.
Let me stay with Campbell's soup. Andy Warhol may have turned it into an innovation for the art galleries, but for most people, Campbell is soup, and few industries are more functional than the food business. Let's look at Campbell's case in more detail.
Only 5% of Campbell's products are new each year. Sales of existing products, most of which have been in the market for years, are highly predictable. They allow Campbell to satisfy more than 98% of demand immediately from finished goods stock. And even the few new products are easy to manage. They have a replenishment lead time of 1 month and a minimum market life cycle of 6 months. When the product is introduced, Campbell deploys enough initial supply to cover the most optimistic forecast for demand in the first month.
If the product takes off, more can be supplied before stocks run out. If the product flops, the 6-month worst-case life cycle affords plenty of time to sell off the excess stocks. Campbell's already high service level of more than 98% means that there is little room for improvement in market mediation costs. Campbell's will thus concentrate on improving what it already does well, and that is efficient delivery.
Yes, well, allow me to play devil's advocate here, if I may. I have the impression that the model is rather obvious. I mean, what I don't see is how it helps companies to find a solution to the problems which they experience with supply chains.
I agree that the distinction between functional and innovative products and between physical efficiency and market responsiveness seems obvious once stated, yet I have found that many companies founder precisely on this issue. It seems to happen because products that are physically the same can be either functional or innovative. For example, PCs, cars, ice cream, and coffee can all be offered as a basic functional product or in an innovative form. It's easy for a company to gravitate from the functional to the innovative without realizing that anything has changed. Let's go back to the model to see how this happens.
It is logical that the stability of the demand for functional products invites competition. The result of extensive competition is often low profit margins. So to avoid low margins, companies introduce innovations to give customers an additional reason to buy and to justify a higher price. Fashion apparel, or PCs, are obvious examples, but sometimes we see successful innovations where we least expect them. For example, in the typically functional category of food, companies such as Ben & Jerry's, Mrs. Fields, and Starbucks have tried to gain an edge with designer flavors and innovative product concepts. Innovation can allow a company to capture higher profit margins, but the very newness of innovative products makes their demand unpredictable. Also, the life cycle of innovative products is short, usually just a few months. What will happen is that imitators will erode the competitive advantage of existing innovative products. The result is that companies are forced to introduce a steady stream of new innovations. Because these changes happen gradually, companies are often unaware of them and continue to emphasize efficiency in their supply chain. As a result, there is now a mismatch between the nature of demand and the priority of the supply chain.
So, how frequently do these mismatches occur?
Well, one rarely finds U.S. companies in the lower left corner of the matrix, those that have a responsive supply chain and a functional product, but many in the upper right cell where they have innovative products but a supply chain geared towards efficiency and low cost rather than speed.
But surely managers must notice the problem in such a situation very early on. Why does it take them so long to react?
For one thing, the cost of this mismatch is often invisible. It's just not something which is measured and tracked. What managers do notice is that their service level has declined mysteriously or that inventories have grown to an alarming level. When this happens, they look longingly at their competitors who haven't changed their product strategy and therefore have low inventories and high service. They may even steal away their vice president of logistics, reasoning that if we hire their logistics guy, we'll have low inventory and high service too. This new vice president invariably designs an improvement agenda based on his old environment. That is to say, cut inventories, pressure marketing to freeze their forecasts well into the future, and establish a rigid, just-in-time delivery schedule with suppliers. The worst thing that could happen is that he actually succeeds in implementing this agenda, because it's exactly the wrong strategy for the company's unpredictable environment.
Yes, I see that now. And I can also see that once a company has positioned its product families in the matrix, the first priority is to resolve any mismatches. Shall we now see how these mismatches can be remedied?
Sounds logical to me. Go ahead.
Well, I suggest we start with the innovative product in a supply chain geared towards efficiency. In other words, let's address the question of how we can get out of the upper right corner.
If you're in the upper right corner, you have two choices. You can move down by making your supply chain responsive, or you can move to the left by making your products functional again. Examples abound here. In industries such as computers, consumer packaged goods, and cars, an increase in the number of competitors and efforts by existing competitors to increase profit margins have led companies to try to turn traditionally functional products into innovative products. But they have often continued to focus on physical efficiency for supplying those products. So in each case, we find companies with products firmly positioned in the upper right-hand corner.
And yet, it's exactly in those industries that you find a plethora of professionally trained managers.
That's right. Let me give you an example from the computer business. When I graduated from college, I worked in an IBM sales office helping to market the System 360 mainframe. I was shocked to learn that IBM was then quoting a 14-month lead time on this hot new product. I asked how I could possibly tell a customer to wait that long. The answer was that if a customer really wanted a 360, he or she would readily wait. Moreover, if I couldn't convince them to wait, there must be something seriously lacking in my persuasion skills. That answer was actually correct. I mean, as far as the readiness to wait was concerned, lead times of 1 or 2 years were the norm in the computer industry. This meant that manufacturers had plenty of time to organize their supplies around physical efficiency.
20 years ago, a company could supply an innovative product with an unresponsive process because the market allowed it. Now, PCs and workstations have replaced mainframes as the dominant technology, and the acceptable market lead time has dropped from years to days. Yet many computer companies have largely kept their emphasis on physical supply efficiency and consequently find themselves in the upper right cell of the demand-supply matrix.
So what's the result of this situation? What I mean is, what's been done about it?
It's definitely caused a kind of schizophrenia in the way computer companies view their supply chains. They cling to measures of physical efficiency, such as plant utilization and inventory turns, because they are familiar. Yet market forces keep pulling them back to responsiveness measures, such as product availability.
Dell offers us a good illustration of one way to get out of the upper right corner, namely by moving down and making the supply chain responsive. They have developed a highly responsive process for assembling PCs to order, so that you can now order a Dell PC to your own liking over the internet, and it is delivered the next day in the States. Another way for companies in the upper right corner to overcome the schizophrenia is by making the products functional again.
What are the criteria for a move towards the left or a move down?
The correct direction depends on profit margins. If there's enough additional profit margin to be gained from product innovation to cover the extra cost of making the supply system responsive, one should move downwards. In contrast, a sign of a need to move left is a product line that has frequent introductions of new variants, but low margins. Toothpaste is actually a good example.
Toothpaste? You know, I wouldn't have thought of toothpaste in this context in 1,000 years.
Maybe I wouldn't have either if it weren't for the fact that a few years ago, I had to give a presentation to a food industry group. I wanted to show the dysfunctional level of variety that exists in many grocery product categories. And I decided a good way would be to buy one of each type of toothpaste of a particular manufacturer. When I got to my local supermarket, I picked out a brand and was amazed to discover it came in 28 variations. But I bought one of each anyway. You could try this experiment, but I got to warn you, they look at you kind of funny at the checkout counter when you buy 28 kinds of toothpaste. When I got home, I examined my purchases and discovered that the ingredients were basically the same. All the differences were cosmetic, mostly packaging. A few months later, I related my story to a senior vice president at a competing manufacturer, and he told me that they also had exactly 28 kinds of toothpaste, one to match each of the competitors' products. Does the world really need 28 kinds of toothpaste from each manufacturer?
Procter & Gamble, which has been simplifying many of its product lines and pricing, is coming to the conclusion that the answer is no. Toothpaste is a product category where a move to the left probably makes sense, at least in terms of reducing the large number of new variants that don't offer significant customer benefits.
Still, there must be companies where the answer cannot be as black and white as in the case of computers or toothpaste, for instance.
Sure there are. The auto industry is a classic case in point. Several years ago, I was involved in a study at a Big 3 auto plant to measure the impact of option variety on productivity. As the study began, I wanted to understand variety from the customer's perspective. So I visited a local dealer and went shopping for the car that was produced in the plant we were to study. From the sales literature that was provided me by the dealer, I determined that when one took into account all the choices for color, interior combinations, and other options, the company offered 20 million versions of the car. But since ordering a car entails an 8-week wait for delivery, more than 90% of customers buy their car off the lot. The dealer told me he had 2 versions of this car on his lot, but if they did not exactly match my ideal specifications, you might be able to get what I wanted from another dealer in the Philadelphia area. When I got home, I checked the phone book, and I found that there were 10 dealers in the Philadelphia area. So, assuming the other dealers also had 2 of the car in stock, I would be choosing from a selection of at most 20 versions of a car that could be made in 20 million versions. So the auto channel is kind of like an hourglass with the dealer at the neck.
At the top of the glass, plants which introduce innovations every year can provide an almost infinite variety. At the bottom of the glass, numerous customers with diverse tastes could benefit from variety but can't get it because of dealer practices at the neck of the glass.
Interesting. But how can this problem be fixed?
Many suggestions miss the mark because they propose a single solution for the entire industry. In other words, they overlook the fact that some cars, such as this Ford, are inherently functional, while others, such as the BMW Z3 Roadster, driven in the James Bond movie, GoldenEye, are innovative. These kinds of cars require different channels. A lean, efficient channel is exactly right for functional cars, but totally inappropriate for innovative cars.
So, if I understand correctly, it's wrong for innovative car manufacturers to switch to the just-in-time system, which auto companies have so vigorously adopted in the last decade.
Absolutely. Innovative products require inventory buffers to absorb uncertainty in demand. And if one looks at the most efficient place to put buffers in the supply chain of an innovative product, it's in parts. This directly contradicts the just-in-time system. In fact, one of the enduring anomalies of the auto industry is that the just-in-time system has reduced parts inventories in plants where keeping inventory is relatively cheap to just a few hours. At the same time, stocks at dealers for whom holding inventory is very expensive have ballooned to around 90 days.
Exactly. I can see the point clearly now. So what are the organizational consequences for a company with different product families and different supply needs?
The biggest problem is the temptation to use a single supply chain with the same priorities for both products. They need to be especially careful to recognize the 2 classes of products and their different supply needs. But if they do this, producing functional and innovative products in the same plant can actually work quite well. Because the functional products have a long life cycle and predictable demand, we can safely produce them to inventory well in advance of when they actually sell. This means we can keep plant capacity available to quickly produce the innovative products as they are selling, then make functional products to inventory to keep the plant fully utilized during periods when demand for the innovative products is low.
I see. Well, that makes sense. But what about the other mismatch in your matrix? That's to say, the responsive supply chain for functional products.
Well, as I said before, this occurs less frequently because in essence it is a situation which is a waste of resources. You might find it applies to startup companies who do not yet have enough business to use all of their capabilities, or in declining industries where there is overcapacity. We can also see an example of this in healthcare. People in the U.S. will sometimes use an emergency room for routine illnesses like a cold.
It's funny you should mention healthcare. I was just going to ask whether these mismatches, or indeed the entire model, also apply to services.
Well, there are some similarities. If we take healthcare, we can think of an emergency room as a responsive supply chain. It's designed to be fast and able to respond to a wide range of unpredictable problems. But it's expensive and inefficient compared to other forms of healthcare. True emergencies are like innovative products. They need the speed and responsiveness of an emergency room. Failure to get treatment when needed is like a stockout and could result in death. So just as with innovative products, stockouts are expensive. Colds, on the other hand, or other routine medical procedures, are like functional products. and hence treating them in the responsive emergency room, is an example of the responsiveness functional mismatch, just like we see in the matrix. We can also think of credit at a bank as an innovative service product if the cost of getting it is not as important as the speed with which you can get it. But back to your initial question as to whether the matrix also applies to services, the answer is that a lot more research needs to be done. For instance, in services, there are many other ways to add value than by product innovations. The time at which you can provide the service, for example. Often it seems that innovative services can be built around functional products, such as the home delivery of groceries ordered off the internet.
So, for those of you in the service sector, there may be some serious homework in this model, or definitely some challenging food for thought. Now that we've tackled the mismatches in the demand and supply matrix, we can concentrate on the improvement of the matches. Let's begin with the efficient supply of functional products. Efficiency and cost reduction are traditional goals for companies. It's what most companies have tried to do in the re-engineering wave. So this should be familiar ground for our viewers, since most of them have been at it for years.
You're right, but some new twists to this old game are emerging. As companies have aggressively pursued cost-cutting over the years, they have begun to reach the point of diminishing returns within their own company. The greatest opportunities to improve performance are now found in better coordination with suppliers and distributors. Happily, this view has coincided with the emergence of electronic networks that facilitate closer coordination.
Can you name companies that have been particularly good at this?
Yes. At the risk that you start thinking I'm being paid every time I mention them, Campbell is a perfect case in point. In 1991, Campbell launched a program with its most progressive retailers called Continuous Replenishment. Continuous replenishment is the mainstay of a grocery industry initiative known as Efficient Consumer Response. It works like this. Campbell establishes an electronic data interchange with retailers who transmit each morning their recent demand and current level of inventories of all Campbell products. Campbell uses this information to forecast demand and to determine which products require replenishment. They do this on the basis of upper and lower inventory limits, which have previously been established with each retailer. The next day, trucks with the required replenishments leave the plant for the retailer's distribution center.
Let's not forget the most important point. Since soup is a functional product with price-sensitive demand, the goal of Campbell's initiative was physical efficiency. The in-stock availability of Campbell products at a retailer's distribution center increased marginally, from 98.5% to 99.2%. However, the big gain was the reduction in retailers' inventories. The program of continuous replenishment cut the inventories of 4 participating retailers from about 4 to 2 weeks. This improvement was possible because Campbell slashed the delivery lead time and also because Campbell knows the inventory of all retailers. As a result, it can deploy inventory of each product where it is needed most.
What does that improvement mean in financial terms, Professor?
Well, grocery retailers often report that the cost of carrying the inventory of a given product for a year, that is 52 weeks, equals 25% of what they paid for the product. So a 2-week inventory savings represents a cost reduction of 2 weeks divided by 52 weeks times 25%, or about 1% of sales. Now, profits in the grocery retailing industry average about 2% of sales. So a 1% cost reduction added to the 2% existing profits raises profits to about 3% of sales, or a 50% profit increase.
So improving physical efficiency was for Campbell the achievement to double the inventory turns of those retailers who participated in the continuous replenishment initiative. What was in it for Campbell itself?
Increased sales. If retailers make more money on Campbell products, they have an incentive to carry a broader line of Campbell products and to give them more shelf space. Campbell has found that sales of its products by retailers who participate in the continuous replenishment program are growing twice as fast as those of other retailers. More importantly, however, in thinking for the retailer, Campbell learned a crucial lesson for its own business. It made them aware of the negative impact that price promotions can have on physical efficiency. Let's explain this graphically.
This is a year from August 1st till July 31st. This is the volume of cans of chicken noodle soup. These are the consumer purchases over the given period, while these are Campbell's shipments. The contrast between the two gave this graph its title, How Campbell's Price Promotions Disrupted Its Supply Chain. For this is what happens. In January, the month in which Campbell's offers a deep discount on chicken noodle soup, the big spike in shipments occurs. Retailers respond to the price cut by stocking up, in some cases buying a year's supply, a practice the industry calls forward buying.
Nobody wins on this deal. Retailers have to carry the year's supply, and the shipment bulge adds to costs throughout the system. For example, the chicken deboning plants have to switch to overtime work from October onwards in order to meet the bulge. Recognizing this, Campbell prohibited its retail customers on continuous replenishment from forward buying at a discounted price. Instead, retailers who promote Campbell products in their stores by offering discounts to consumers can either pay an everyday low price, which equals the average price that a retailer who receives promotional deals would pay over a year, or pay a discounted price, but only on the quantity that is sold through to the end consumer. There is an important principle about the supply of functional products lurking in this example. Consumers of functional products offer predictable demand in exchange for a good product at a reasonable price. The challenge is thus to avoid actions that would destroy the inherent simplicity of this environment. Many companies violate this dictum because they get hooked on price promotions. They start by using price incentives to pull demand forward in time so that they are able to meet a quarterly revenue target. But pulling demand forward helps only once. The next quarter, demand has to be pulled forward again just to fill the hole created by the first incentive. The end result is an addiction to incentives that turn simple, predictable demand into a chaotic series of spikes that only add to cost.
Less costs for Campbell and a higher return for the retailer. It sounds to me as if Campbell has found an ideal partnership or a win-win deal with its retailers. Are there any pitfalls in this approach?
Yes. If your retail partner isn't sophisticated enough to recognize the value you have created for them, you'll be incurring an additional expense for no benefit. But many retailers are becoming increasingly sophisticated in evaluating their suppliers. The Campbell story definitely illustrates a different way for supply channel partners to interact in the pursuit of higher profits. Functional products, such as groceries, are highly price sensitive, and negotiations along the supply chain can be fierce. If a company can get its supplier to cut its price by a penny, and the company's customer to accept a 1-cent price increase, it can have a tremendous impact on profits. In this competitive model of supply chain relations, costs in the channel are assumed fixed, and therefore profits are fixed, and the manufacturer and retailer compete through price negotiations for a bigger share of the fixed profit pie. In contrast, Campbell's continuous replenishment initiative embodies a cooperative model in which both manufacturer and retailers cut channel costs, thereby increasing the size of the profit pie to be divided.
Again, it sounds too good to be true. I guess Campbell's program must have been imitated immediately by a lot of other producers of functional products.
The cooperative model is indeed powerful, but there are pitfalls. Too often, companies reason that they can never have too many ways to make money, and therefore try to play a cooperative and competitive game at the same time. This is tricky because the two approaches require diametrically different behavior. Consider information sharing, for one thing. If you are my supplier and we are negotiating over price, the last thing you want to do is fully share your cost information with me. But this is exactly what we both must do if the aim is to cooperate and reduce channel costs by assigning each task to whichever of us can perform it at least cost.
Yes, I see. Well, this ends our discussion of the first match in the demand-supply matrix. Let's now turn to the other one and see how the responsive supply of innovative products can be improved. As we have seen, the main difference between functional and innovative products is the uncertain demand of innovative products. Is this also the starting point in improving the responsiveness of the supply chain for innovative products?
Yes, it is. Although it may sound obvious, I have found that the first step is simply to accept that uncertainty is inherent in innovative products. Companies that grew up in an oligopoly with less competition, more docile customers, and weaker retailers find it hard to accept today's levels of demand uncertainty. They declare high forecast errors unacceptable and virtually command their staff to think hard and long enough to achieve forecast accuracy. But uncertainty cannot be removed by decree.
So what would you recommend them to do?
With innovative products, uncertainty must be accepted as good. If the demand for a product were predictable, that product would probably not be sufficiently innovative to command high margins. The fact is that risk and return are linked, and the highest profit margins usually go with the highest demand risk. Once a company has accepted uncertainty, it can begin to manage it. And there are 3 different ways to do this.
All right, so let's see what they are.
A company can first of all continue to reduce uncertainty as much as possible. For example, by finding new data sources that can serve as leading indicators. It can avoid uncertainty by cutting lead times and increasing supply flexibility. The aim is then to produce to order, or at least to produce at a time closer to when demand materializes or to when it can be accurately forecast. Finally, once uncertainty has been reduced or avoided as much as possible, a company can hedge against the remaining uncertainty with buffers of inventories or excess capacity.
If I understand it correctly, managing uncertainty is usually a mix of reducing and avoiding it, followed by hedging against the remaining uncertainty.
That's right. Let me show you something. See this bike? It's produced by National Bicycle, a division of Matsushita Electric. This company actually provides a good example of responsive supply achieved by avoiding uncertainty. Let me tell you the story. For years, National Bicycle prospered as a small but successful division of the much larger Matsushita Electric. But by the mid-1980s, they were in trouble. Bicycles in Japan were functional products bought as an inexpensive means of transportation. In other words, a commodity sold on the basis of low price. Japan's high labor costs left National Bicycle unable to compete with cheap bikes from Taiwan and Korea.
To remedy the situation, in 1986, Matsushita appointed a new president, Makoto Komoto, an executive from another division who had no experience in the bicycles business. He began by taking stock of national strengths, which he saw as technical expertise in manufacturing and computers, a highly skilled workforce, a strong Panasonic brand name, and a network of 9,000 dealers. Komoto also saw that National Bicycle had a high-margin line, namely sports bikes that more affluent customers bought purely for recreation. He concluded that National's best hope was to focus on this segment and to use the company's strengths to develop a responsive supply process. He envisaged a system in which customers visited a dealer, chose a bike from a selection of several million combinations of size, color, and components, and then had their order faxed to the factory. There, computer-controlled equipment and skilled workers would make the bike and deliver it to the customer within 2 weeks.
And did he manage to make his dream come true?
Yes. In 1987, Komodo's vision became a reality. By 1991, National Bicycle's custom order business was in the black, and it had grown its share of the sports bike market in Japan from 5% to 29%. It was also meeting the 2-week lead time 99.99% of the time.
But is a 2-week lead time acceptable to customers?
Yes, but only because they get a lot in return. Don't forget that the number of choices has increased from just a few types of bikes to 2 million.
But how does National Bicycle manage to do this when it has little idea what customers will order when they walk into a retail shop? Can you explain this in more detail?
Sure. Let's go through the National Bicycle supply chain together.
Right.
We start with 10 types of tubes which can be cut and welded into 300 different frames. A frame can be painted in 70 different colors, so that gives us 70 times 300 or 21,000 types of painted frames. Then the different types of components are added. There are 10 versions of each component on average, but since there are many types of components, such as wheels, shifters, brakes, etc., the number of combinations is much greater. Typically, each painted frame can be assembled with about 100 different combinations, which means that there are 2 million types of bicycles that can be shipped from the plant.
Why do product versions reach 3 billion by the time the supply chain reaches a retailer? Does the retailer change the bicycle in some way?
No, but we can think of the geographic location as another form of differentiation. Since National Bike has 1,500 retailers participating in this program, the number of bicycle location combinations is 1,500 retailers times 2 million bike versions, or 3 billion bicycle location combinations.
Goodness, dealing with all that complexity must be incredibly tough.
It would be, except that the National Bicycle supply chain is fast at the point where variety becomes large. Let's have another look at the supply chain.
While it takes up to 40 days to acquire tubes and components, no further step in the process takes more than 2 days. Because they only have 10 versions of tubes and of each component, they can keep them in inventory and hence provide instant availability even though their lead times are long. And because they're fast everywhere else, the high variety doesn't hurt them.
I see. The general principle seems to be that at each point in the supply process, you need to have either a short lead time or low variety.
That's right.
And can our viewers use this concept?
Sure they can. The beauty of this concept is its simplicity. All you need to do is map your supply chain and determine the number of product versions and lead time at each step. Then look for steps with high variety and long lead time. That's the place to focus your energy if you want to increase the responsiveness of your supply chain.
How can you fix things if you see a long lead time, high variety step?
Well, the obvious approach is to either cut lead time or cut variety, but there are less obvious approaches. For example, you can improve responsiveness by reversing the order of a short lead time, high variety step, followed by a long lead time step that doesn't add variety.
Getting back to National's overall make-to-order idea, are other companies doing this too?
Yes. National's program is a leading example of a new movement called mass customization. That is, the ability to customize a large volume of products and deliver them at close to mass production prices. Many companies have adopted a mass customization strategy.
But are there challenges in this strategy?
Yes. For example, you might wonder what National Bike does with its custom plan in the winter when no one is buying bicycles. Well, it solves this problem by making their high-end, make-to-stock bikes during the low-demand winter months.
I see. So these are the bikes for those who want it immediately and don't want to spend as much as a really made-to-order one would cost. Smart thinking. But if I go back to those expensive made-to-order bikes, there must be a cost factor, or have I got this wrong? I mean, Isn't this the opposite of Henry Ford's idea with the Model T production? We can hardly have economies of scale here, can we?
No, but your analogy is very sharp. Mass customization is not necessarily cheap. National's custom production requires 3 times more labor than assembly line production. This differential is the same one that Henry Ford encountered in the early 1900s when he moved in the opposite direction from craft to mass production and cut labor costs by a factor of 3.
So, what has changed to make custom production viable now?
The customer has changed. Today, we have more affluent customers willing to pay a high margin for innovative products. And products like that require a more expensive but more responsive production process than the functional Model T. If we go back to the ways in which uncertainty can be managed, National Bike is a good example of avoiding uncertainty. To illustrate how the 3 ways of avoiding, reducing, and hedging can be blended, we go now to Aspen, Colorado, where we find Sport Obermeyer, a leading fashion ski wear producer.
Okay.
Obermeyer distributes its fashion ski wear through 800 specialty retailers located all over the United States. Because 95% of its products are new each year, it constantly faces demand uncertainty and the associated costs. In 1991, Vice President Wally Obermeyer launched a program to attack these costs. Obermeyer invited its 25 largest retailers to Aspen in February, 1 month before the usual March skiwear show, and asked them to evaluate Obermeyer's new line and place their orders early. Obermeyer found that the early orders from this handful of retailers allowed it to forecast national demand for all of its products with an error of just 10%.
So that's how Obermeyer reduced the uncertainty.
Indeed. But nice as it was to get this information several months before Obermeyer was required to deliver its products, it didn't solve the company's problem completely. The long lead times forced the company to commit production well before February. Wally Obermeyer then concluded that each day which the company managed to shave off lead time would save $25,000.
How did he get to such an incredible amount per day?
Because that was the amount the company spent each day at the end of September on sending their products by air from plants in Asia in order to have them in the store at the start of the retail season. Each day they cut off their lead time would save 1 day of air freighting. Once this number was announced, Obermeyer employees found all kinds of ways to shorten the lead time. For example, the person who had dutifully mailed design information to the production manager in Hong Kong to save money realized that the $25 express mail charge was a bargain compared to the $25,000 per day cost of the increase in lead time due to mail delays. Through efforts of this kind, Obermeyer was able to cut lead time enough that they could produce half of their units after orders were received from the 25 retailers who came to Aspen in February. Because forecasts were highly accurate after receiving these orders, they had essentially avoided uncertainty on this half of their production.
But in spite of this improvement, half of the production still had to be committed early in the season, when demand was uncertain. Which styles did they make then?
At this stage, Obermeyer discovered something interesting. Wally Obermeyer had asked the 6 members of a committee responsible for forecasting to each construct a forecast for all products. He then used the average of these 6 forecasts as the company forecast. After 1 year of trying this method, the company found that when the 6 individual forecasts were close to each other, they were accurate. And when they varied widely, they were inaccurate. This discovery gave the company a means for selecting the styles to make early. Using this information together with the cost of over and under production, it developed a model for hedging against the risk of over and under production.
So the model tells the company exactly how much of each style to make inventory early in the season and how much to make after early orders are received from the 25 big retailers in February.
You've got it. Obermeyer's approach, which has been called accurate response, has cut the cost of over and under production in half. This is enough to increase profit by 60%. Retailers love the system because it results in more than 99% product availability. They have given Obermeyer the #1 rank in the industry for service and rewarded them with a 30% sales increase in each of the 2 years after they launched this new program.
And they wouldn't have done that if Obermeyer hadn't performed exceptionally in its effort to align supply and demand. Professor Fisher, this has been most interesting. Do you have any final words of advice for our viewers?
Yes, I do. The ideas we've discussed today appear almost obvious once you understand them. But I've found them to be a powerful way to improve supply chain performance. I would urge all viewers to now think about how to apply these concepts in your organization.
Start by classifying your product families as functional and innovative, and the supply chain for them as efficient or responsive. Second, look for and correct mismatches. The most common mismatch is unresponsive supply of an innovative product. In most cases, you will want to make your supply chain more responsive, but also consider whether you are earning enough margin on this product family to justify the high variety and rapid rate of new product introduction. If not, a more functional approach makes sense. Third, establish appropriate performance measures such as cost and inventory turns for an efficient supply chain, or lost sales and obsolescence for a responsive one. Then audit your current performance and estimate the potential for improvement. This will help you to set tangible gains as you pursue improvement programs. Finally, develop initiatives for improvement.
If efficiency is the goal, supply chain partnerships like Campbell's should be considered to reduce inventory in the channel. With retailers and other downstream partners, seek consumer sales data that will give a more accurate picture of the market, and share data with upstream suppliers so they can plan better and be more efficient. If responsiveness is the goal, think about the 3 ingredients of reducing, avoiding, and hedging against uncertainty, and what is the right recipe of those ingredients for you? Improve forecasts to reduce uncertainty by looking for new sources of data that can improve forecasts, like early orders from lead retailers. Increase flexibility to avoid uncertainty by creating a variety versus lead time supply chain map like we showed for National Bike, and attack the long lead time, high variety steps. Finally, to hedge against uncertainty, estimate the margin of error in your forecasts, measure the costs of over and under supply, and use these to determine the appropriate level of inventory of each component and product you stock. Applying these steps requires energy and patience, but the reward, a remarkable competitive advantage that generates high growth in sales and profits, makes it worth the effort. Good luck.
Thank you, Professor Fisher, and thank you, ladies and gentlemen, for joining us today.